All right, so we have a cylinder, right, and it has a radius of 4, it has a height of 10, and it's filled to 10% capacity, right? And then what the question's asking for is we want to know what capacity the second cylinder will be filled if it's poured into the second cylinder, right? So we have an original cylinder, let's just call it original, we always want to write our workout, and it has, let's just say, radius and height, and let's call it percent capacity, right? So it has a radius of 4, it has a height of 10, and it's filled to 10% capacity. The volume of a cylinder, right, we'd want to use volume for this, is going to be pi r squared times h, right? So r squared, let's square this, 16 times 10 is 160, and if it's filled to 10% capacity, 10% of 160 is 16, and we can have a pi on the end there, right? Pi r squared h, again, pi r squared h, 4 squared times 10% of that, 16 pi, right? Then we have this new cylinder, right? And what does it have? It has a radius of 8, it has a height of 2, and we want to know to what capacity the second cylinder will be filled. So let's find the volume of this new cylinder. This is going to be 8 squared times 2, which is going to be 64 times 2. 64 times 2, put in your calculator, is 128 pi, right? And that's the volume of this cylinder, right? So we want to know if we have our liquid is 16 pi, right? Because if it's filled to 10% capacity, we had 16 pi of liquid here. So what percent is this of this? 16 pi of 128 pi is going to be, put in your calculator, it's going to be 12.5%. Answer choice C.